Greetings to all. Today I am going to present about convolutional neural network, commonly known as CNN. CNN are one of the most important deep learning models used in computer vision. They help computers understanding and analyze images just like human recognizes object visually. In this presentation, we will explore the architecture of CLL, understanding how they work, and discuss their real-world applications. Before understanding the complete working process, will first look of the basic architecture of CNN. A CNN consists of multiple layers that work together to the process image data. The major layer including convolution layer, activation layer, pooling layer, fully connected layer. Each layer has specific functions. Thus, convolutions layer extract the important features. The activation layer introducing non-linearity, pooling reduced to the dimensions, and fully connected layer perform the final classifications. This layer is structured allows CNN to efficient learning patterns from the image. So the CNN highly effective because of three important properties. First is practical inversion. CNN can recognize object even if their position changes within the image. For example, whether cat appears on the left or right side of the image, the CNN can still identify it. Second is weight sharing. The same filtering is applied across the entire image. This tracing reduced the number of parameters and make the model of computational efficient. This is local connectivity. Each neuron focuses only one small the image instead of the entire image. This helps the network capture local features like edge, textures, and safe effectively. Beyond these advantages of CNN is outperforms traditional artificial neural network in image related tasks. So computer read the images matrix of pixel values for colored images. The dimensionals are usually represented n into n into 3, where 3 represent the RGB channels. The convolution layer uses filters, also called kernels, to scan across the image. The filter performs mathematically operations called a dot product. As the filters slide over the images, it increases the activation map or feature map. This feature map is highlighted important patterns such as edge, corner, texture, safer. The example shown here demonstrated how filters values multiple the pixel values and produce the final output. This process helps the CNN extract meaningfully important from raw images. After features extractions, the next step to introducing the non-linearity into model. So R, R so ReLU stands for the rectifier linear unit. It is the one of the most commonly used activation functions in deep learning. The main purpose of ReLU is introducing the non-linearity into network. Without non-linearity, the neural network would behave like simple linear model and would not be able to learn complex pattern. RO works very simple. If the input value is positive, it keeps the output value. If the input values are negative, it is converted to 0. This improves the computational efficiency and also helps solving the vanishing gradient problem. As a result, CNN train faster and perform the better. Once features are activated, we need to reduce the image size and data while preserving the important information. This achieved using pooling layers. Pooling layers reduce this particle dimension for feature map. This means they reduced the width and height of the data representation. The advantages of poolings are reduced computations, fewer parameters, reduced overfitting, faster processing. There are two common types, max pooling, average pooling. Max pooling selected the maximum value of region while averaging pooling calculated the average value. Pooling help retain the most important features while simplifying the data. So CNN became the globally popular in after breakthrough model called AlexNet. Then let us see how changed the field of computer visions. One of the biggest millstones in the CNN history was AlexNet in 2012. Before AlexNet, traditional computer visions technical struggling with large and complex data sets. AlexNet introduced the deep CNN combined with the GPU and RLA activations. It is the performance of the ImageNet competition was revolutionary. It is the strategically reduce the top 5 error rate and achieve higher accuracy than previous method. This successfully marked the beginning of the model deep learning era. After AlexNet, CNN became widely adopted the research and industry. Now, let us summarize the complex workflow of CNN from input and image to final output. This slide shows the complete CNN pipeline. So, step 1, input layer. The raw images pixels are given to the input. Then step 2, convolution plus RLA filters extract the future and RLA introducing non-linearity. Step 3, polling layer reduce the dimensionality while preventing key information. Fourth one, fully connected layer. They extract the future or planted and pass to the fully connected neurons. Step 5, output layer. Finally, the network predicts this class labels such as cat, dog, or human. This pipeline allows CNN to automatically learn hierarchical image features. Among pooling methods, maximum poolings and average poolings are most common. Let us compare them. This table compares maximum pooling and average pooling. Maximum pooling selected the value from a region. Focus on the strongest feature commonly used for edge and future predictions. Average pooling calculate the average value, produce the smoother future map useful for the reducing noise. In practice, maximum pooling is more widely used because it is prevent dominated future efficiently. So evaluation of accuracy. This graph illustrated the evaluation of CNN architecture over time. Starting from LNet, CNN model gradually became a deeper and more powerful. AlexNet introducing the major breakthrough with GG 16 degrees depth in smaller filters. GoogleNet has improved the efficiency with the inspection scale recently introduced the additional connections allowing extremely deep networks. As architectures evaluated in image recognition accuracy improved dramatically today, CNN based achieve near human or even superhuman performance in many tasks. Because of this high accuracy, CNNs are now used in many real world applications. Let us discuss some important examples. CNN are widely used in many industries. First, autonomous driving. CNN helps self-driving car detecting traffic sign, vehicle and road land in real time. Second, medical imaging. CNN's assistant doctor identify tumor and abnormalities, X-rays and MRI scans, CT scans. Third, facial recognitions. CNN are used biometric authentication system for smartphones, earbuds and security applications. Finally, let us concluding the presentation. Thank you for your attention.